See someone kick a soccer ball. The force of their foot is making the ball go forward. We define force as a push or pull. Forces affect motion. They can make something move, make something change directions, make something stop, or even keep something from moving. Force usually involves an energy transfer from one thing to another. In this example, the moving ball hits the ball that is standing still. The moving ball has what we'll call energy of motion. When it hits the other ball, the energy of motion is transferred to the ball that is standing still, causing it to move. In the case of the soccer player, energy is being transferred from the player's foot to the ball. The more energy that builds up in the player's foot as he or she swings it, the more energy of motion that is transferred when the soccer ball is kicked, and the farther the ball will travel. Forces are at work all around us, but forces do not have to touch an object to make it move. These are what are called non-contact forces. One non-contact force you already know very well is gravity. When you drop something and it smashes on the floor, well, that is gravity at work. We usually think of gravity as the force that pulls everything to earth, like an apple falling from a tree. When a basketball player aims at the basket and shoots the ball, she is counting on her skills to throw the ball to the hoop. But she is also counting on gravity to make it fall through the net. But gravity is really much more than that. In fact, gravity is at work throughout the entire universe. Every planet and sun and moon and star has gravity. And it is all of their gravitational forces that hold the universe together. There is another force you already know. It is called friction. While gravity is a force that exists between objects without their touching each other, friction is very much a contact force. Let's look at a soccer player. When the player kicks the soccer ball through the air, it goes a certain distance. But when the player kicks the ball just as hard on the ground, the ball does not go nearly as far. Do you know why? It is because of friction. Friction is the resistance that a surface or an object meets when it moves over another surface or object. In the case of the soccer ball, the surface of the ball rubs against the surface of the grass, and that slows it down, finally making the ball come to a stop. Why did the ball go so much farther in the air? There is resistance in the air too, from all the gases and particles that make up the atmosphere. But the friction caused by the air is much less than that caused by the grass. Airplanes are subject to friction from the air when they fly. To reduce the friction, the bodies and wings of airplanes are designed so that air can move over them more quickly. How much friction there is between two surfaces or objects depends on how much of the surfaces come in contact with each other. For example, dragging a heavy box on the floor would take a lot of energy because the whole bottom of the box is rubbing the floor. But if you use furniture moving pads under the box, moving it will be much easier. The pads reduce the amount of surface area that is touching the floor, which means less friction and less energy required to move the box. The pads also have an especially smooth surface that helps reduce friction. Ice skating is another example of how friction can be reduced. When the metal blades on the bottom of the skates rub against the ice, the heat caused by the friction between the two surfaces melts the ice, forming a thin layer of water, which allows the skaters to glide around the rink with very little effort. Gravity and friction are important forces for many things we do. A roller coaster is a great example of how these two can work together as a team. When the ride begins, the coaster is pulled to the top of the first hill. When it starts down the other side, gravity takes hold, and the cars build up a lot of energy of motion as they go streaking to the bottom. Some of this energy becomes heat and sound as the coaster travels down the hill to a stretch of level track, where some of the energy of motion is transferred to stored energy. As the coaster continues on, energy is transferred back and forth from stored energy to energy of motion as the cars go up and down the remaining hills. All along the way, more energy is lost as it becomes heat and sound, and the coaster slows down. Eventually, a brake, which applies friction to the turning wheels, is used to bring the coaster to a complete stop. Gravity and friction are at work all around us all the time. Watch for them and see how many different ways you can find that they affect the motion of things.